Hi, grade 7. This is lesson 1-8. It's page 48, and it's numbers 5 through 41, the odds, and also page 40, or problem 42 and problem 43. When you do this assignment, yes, I'm expecting to see more than just an answer. I'm expecting you to show your steps so that I know you know how to do these problems. Okay, so let's start by taking a look at something that should be relatively easy. Let's say we have the problem x plus 3 equals 4. Now, I know you can look at this problem and probably solve it in your head, but the idea of today's lesson is to use inverse or opposite operations to solve these problems. And we've had this last year, so this should be review. When we look at this problem, the middle of the problem is right here. It's the equal sign. The left side is supposed to be equal to the right side. But we don't know what x is yet because x is attached to this 3. What's the opposite of adding 3? Well, last year we learned that the opposite of adding 3 is subtracting 3. And so I do it to both sides of the equation. To both sides of the equation, I do the opposite of adding 3, subtracting 3. And then I solve. X is 1. X is 1. 1 plus 3 is 4. Okay, let's try it with a different one. What if it's x minus 5 equals 2? X minus 5 equals 2. Again, x is attached to this 5 by subtraction. What's the opposite of subtracting 5? The opposite of subtracting 5 is adding 5, and so I do that to both sides. And when I do it to both sides, x ends up being 7. Okay, do you remember this from last year? Hopefully you do. Let's do another one right here. What if I have t minus 4 equals negative 1? T is attached to the 4 by subtraction. What's the opposite of subtracting 4? Adding 4. And I'm going to do it to both sides. I'm adding 4 to both sides. And when I do that, I get t equaling whatever this is, and it happens to be a positive 3. Positive 3. How about something like this problem? 17 equals b boy minus 8. This time the variable's on the right side of the equation. The previous problems all had the variable, the letter, on the left side. Now we got it on the right side, but it's still attached to something, this 8, by subtraction. And so I'm going to do the opposite of subtracting 8, which is adding 8, and I'm going to do it to both sides. And when I do it to both sides, I get a b value of 25. 25 minus the 8 is the 17. Let's try another one with the variable on the other side. What if we had 16 equaling 24 plus p? 16 equals 24 plus p. The variable's attached to 24 by addition. What's the opposite of adding 24? Well, the opposite of adding 24 is subtracting 24. And you'll notice I'm going to do this to both sides of the equation. Subtract 24, subtract 24. That's the opposite of adding 24. And when I do that, I get p on the right side, and I get negative 8 on the left side. 16 minus 24 is negative 8. But why is it negative 8? Remember our rule about subtraction? To subtract, you add the opposite of the second number. And when you do that, this is now a 3-step rule. So we think about their absolute values and subtract them. This happens to be negative 8 because 24 minus 16 is 8. And this one has the bigger absolute value, so we're going to share its sign with our answer. How about the next one? What if I have y plus 37 equals 59? Our y is attached to the 37 by addition, So the opposite of addition is subtraction. And we get y equaling 22 when we do that. Okay, so 6 problems so far. Let's wipe them off the board and do some more. How about something like this? R plus 53 equals negative 20. The r is attached to 53 by addition. The opposite of adding is subtracting. So I am going to subtract 53 from both sides of the equation. Over here, I end up with r. These cancel out, leaving me with r. Here it's a little bit tricky. Minus or negative 20 minus 53. To subtract, remember the rule, we add the opposite of the second number. We add the opposite of 53. Now I've got two negative numbers, and the rule says when you've got two negative numbers, you just add them. So r is negative 73. How about this one? 111 equals x plus 68. How are we going to get x by itself here? What's the opposite of adding 68? Well, that's subtracting 68, isn't it? And when we do that, we get an x value on this side, and over here we get 43. X is 43 because 111 minus 68 is 43. Any questions about that? Well, can't really ask them because this is a videotape, sorry. Forgot about that, I guess. Just bad habit of asking that question when we get to the end of a problem sometimes. What about negative 54 equals a negative 32 plus a w? This might be a little tricky. This might be the hardest one so far. What is the opposite of adding a negative 32? Well, you can think of it two ways. You can say the opposite of adding negative 32 is subtracting negative 32. So let's do that. We're going to take this number and subtract a negative 32 from it. And we're going to take this side and we're going to subtract a negative 32 from it. Over here on this side, the 32's cancel each other out, leaving me with w. What do I do with this? To subtract, we add the opposite of that second number, right? Now we've got a positive and a negative value. We're trying to add them. That's the three-step rule. So we think about their absolute values, we subtract their absolute values, and we get a 22. Is it positive or negative 22? Well, we look at the numbers and we ask ourselves, which one of those has the bigger absolute value? This one does, so we're going to share its sign with the answer, negative 22. How about this one? N minus 75 equals 10. What's the opposite of subtracting 75? Well, adding 75, isn't it? So I add 70 to both sides, 75 rather, and I get an n value of 85. Hopefully this helps you remember how to do this. Be careful. You're going to have to remember those adding and subtracting rules of positive and negative integers. Okay? Anyway, if you have any questions, ask me.